Okay, so here's the graph of those ordered pairs. So you could pick completely different inputs for that, and that would be fine, but we would still get the same kind of look of the graph. Even if you don't have the same ordered pairs, you're going to see the same trend. Okay, so does the graph consist of just 5 points? Okay, and it doesn't. Okay, I have 5 points, the ones, the inputs that I picked, but this works for my hours. Whoops, sorry about that. The number of hours can be anything in between 0 and 4. So it's not just those points. Okay, describe any pattern. So I would say that if I look at this, I would say that the graph is forming a line. And I'm going to say even a decreasing line, just to be a little more specific. Because as my number of hours run go up, my number of miles left goes down, and this is looking at a nice steady rate, which really means this is going to be what we're going to call a linear function soon, which you definitely did in 095. You studied a lot of linear functions. All right, so here's our new name. So the other ones, the first two that we started with were discrete because they were only those specific points, we didn't connect it. Okay, this one I didn't yet, but we will in a little bit. I didn't connect that graph, but we could because it goes with a symbolic equation. And this is what we call, when we can write a symbolic equation, the function's said to be continuous. Okay, it means I can plug in infinitely number of inputs and get an output. Okay, so now we're going to look at another one. Okay, so this is a very similar type. We did this in activity 1.2 again. This was a pay function. You made $10.50 an hour. We plugged in number of hours, so that is on my x-axis. We got out gross pay. That was our output. Okay, and we'd already had these ordered pairs. If you look back at page 14, this was a set of ordered pairs we'd already come up with. So I just plotted them. So you should stop the video and just get a good graph. You can use my labels on the H and G axis, X and Y axis. Okay, so you've got a good scale there, and plot them, and then come back and join me. All right, so is this gross pay function discrete or continuous? We would say that this is continuous. Okay, we can connect the points, and we do have a symbolic representation. That symbolic representation is this G equals 10.5. Okay, that equation that goes along with it. Okay. Your calculator a bit now. So you're going to have, in the weekly notes this week, you're also going to have some things to talk about an introduction to graphing on the calculator. Okay, and you did it a little bit last week. So it's just having you graph this is the equation, the symbolic equation that we had for the fill-up problem, where we assumed you had to fill up, you needed 12.6 gallons, and the price per gallon was, your input was the thing that was fluctuating, and your cost of your fill-up was your output. So if you look at this graph, this one's already done for you. It just has a couple ordered pairs plotted. This is another linear function because with that 12.6 is consistent. Okay, so you'll take a look at these next two graphs. Okay, the next one has it connected. If you look at the difference in these two, this is really kind of the practical graph. But the next one that we have over, because the first one is only defined for between 3 and 5 dollars per gallon, which is what we said was practical for that. But if you take a look at this next graph, this is the same function. It's just doing it over all real numbers. So if I took the context out and just graph that whole thing, well, I get the entire line because the actual domain is all real numbers. The practical domain is the one that's limited. Okay, so the next thing down here is just showing you how to change, putting in your y equals, putting in the function. So you, instead of using c and p, you're always going to use y and x when you start graphing. So a function like this down here, I'm always going to put it in as like that, 12.6x under my y. Okay, and so we're going to use the window setup in order to only look at the part of the graph that we really want. So if in the next screen is giving you kind of a little bit of tutorial on how to set your windows, on how to graph, okay? So you've also got a couple other videos this week that's going to help you with that. But it's having you put in a new set of windows so that you can really see the part of the graph that you want, the part that's reasonable to us. If you change your windows down here, this is giving it more of like, what does this function look like overall, not just between 3 and 5. So you're going to get very comfortable over the semester changing windows. Okay, so now our last little graph, I think here. Okay, it comes back to our gross pay earning $10.50 an hour. Okay, so remember this is a good example of how here is the verbal way to write it, and then symbolic. Okay, and then we're going to look at it graphically. So on the next page, it's giving us 5 ordered pairs that go along with this function. This function is just the g equals 10.5h, plugging in if I worked 0 hours, if I worked 10 hours, if I worked 15 hours, and so on, giving us the output and graphing it. Okay, so here again we have a nice kind of linear function. It's forming a line. Linear function, and it's moving at a steady rate, and this rate is $10.5 dollars per hour that I'm making. All right, so here's let's look at a new situation. Everything we've done so far has been from other activities. So sales tax is a function of the cost, right? As your cost of something that you buy goes up, your sales tax goes up. Sales tax is a steady rate, okay, soon to be known as our slope. So define the cost in 4 different ways: verbally, symbolically, numerically, graphically. Okay, so verbally is just that the tax rate is 6% anytime that so let me just actually break this up. So verbally, you pay 6% per amount of cost of item. Okay, so symbolically, okay, that means my total cost, I'm going to use T, is, well, 6% as a decimal would be 0.06 times whatever cost of my item is. Okay, so I multiply by 0.06 my cost. So what I did was they wanted us to fill in this table of values. Your table of values does not have to be exactly the same. It doesn't have to be whole numbers for input, but I did it just to keep it easier. So for each one of these, if it costs $10 for the item, I figured out my tax. If it costs $100 for my item, I figured out my tax, and so on. Okay? And if you take those ordered pairs, so take a few minutes and fill in your table, and then you're going to graph it. Your input is going to be on your x-axis. That's the cost of the item. And then your sales tax is going to be... Actually, you know what? I wanted to correct one thing as I realized I said something wrong. This is not actually my total cost right here. It's not the total cost of my item in my tax. It's actually just my tax. I had said that wrong before. Sorry about that. So what I'm getting out of this function is actually just the tax that I'm paying. I'd have to add back in my original cost. Okay, so take a few minutes, give yourself a nice graph of that, and you'll notice that again, this is going up at a steady rate, and it's a nice linear function. So the end of every activity has a really nice summary, so I always encourage you to take this, think about what you're supposed to end this activity knowing, and the exercises at the end of this are great ways to be, after you do your homework in my math lab, this is a great way to get ready for a test or a quiz by doing these extra exercises at the end. Okay, so have a good week. Let me know if you have any questions.